Yeah, it's okay.
Yeah. So can you can maybe present your challenge?
A certain question from November 2018.
Yes. November
Uh,
2018. So you're looking at the paper for November 2018.
yeah.
Okay, let me write it somewhere. Allow me to write it somewhere, please. Is it possible for you to maybe have you written it somewhere?
Yeah.
Is it possible for you to present it, or maybe can I write?
You can write. I'm using my phone. It's hard to share my screen.
Okay. So the November
18.
November 2018.
Yeah.
So the first question that asks some challenges.
Distinguish between single buffering and double buffering as used in OS.
Single buffering
And double buffering.
and double
buffering. Yeah.
Then let me write it first.
Okay.
Okay. Have you now? We can now go to the next question so that we can answer them all.
Okay. I think that's the only one I had a problem with.
On the whole paper. So on process management, or maybe on the whole paper?
Yeah, that's the only one.
Okay. So what I can say on single buffering,
Yes.
when you look at most of the execution that we have,
Yeah.
We always use some frames.
Yeah.
And when you are using some frames, let me maybe present. Just a minute. So in this case, when you are setting data, we use some frames.
Yeah.
And when you are using some frames, it is when the data is redundant to only one monitor. So we only render when the data setting data that is rendered. Now, when you talk about rendering, we are looking at a point of way of sending data in terms of design. The way we can be able to send data following maybe a certain sequential or a certain form within the execution, which are rendered on one monitor. So it's like now, the moment we look at now, the time that we are maybe doing some presentation, maybe using a projector. So you always render some information to only one screen. Yes, we have a lot of displays that you can have, but you render that information on one monitor. So that is what you call single buffering. But the moment now you can render to different views. Like now, the way I am presenting right now, I'm using what you call double buffering. Because suppose we have about 20 students. Those 20 students are able to receive the same presentation. They're not supposed to receive different presentation. They are supposed to present or to get the same presentation. Meaning, you have your monitor, you're using your phone right now. Somebody else is using a desktop. Somebody else is using a laptop. So all those are different monitors that you can be able to present. And those monitors are now rendered by maybe only one source. So that is what you call double buffering. So single buffering is when you're using only one way of sending data, and we are sending data to only, maybe you can send it to many users, but they are now only focused to that screen or maybe to that monitor. So that is about what you call single buffering and double buffering. where in single buffering, you only have to render data in one monitor or a single monitor. But for this one, you render to different monitors. Are you getting those explanations or those differences that I'm talking about?
Yeah, I've understood.
Yes, because now when you look at now the presentation of data, we always use what you call the double buffering. Remember, when you are accessing your data, you can store it because a buffer is a temporary storage that is mostly used to store either hardwares or maybe some application that you're supposed to set at a given point. So for that time that you're supposed to set, so automatically they must be rendered to different levels or to different areas of executions. So if they are supposed to be rendered in different levels of executions, now that is what you call double buffering. So rendering is now, it's like you are sending some presentations to different users using different monitors, because at that point, the moment I was presenting this PowerPoint, and then I do away with that, it becomes temporary. It becomes temporary. But now, when I look at now the single buffering, this one now becomes the permanent, because now I'm using my computer, I can still retrieve it. But in your case, you will not be able to retrieve it because I was distributing to multiple users within that. I think that is okay. That's a good explanation on that, and that is a good question that we have. I think you have even come up a clause, a word called metaphor. Have you come across the word called metaphor?
Yeah.
What have you understood about metaphor? What have you understood? Maybe giving examples. It's not a must you explain.
I can't quite recall.
But did you get the answer?
Yeah, I did.
Yes, because when you look at a metaphor, we are looking at an interface or presentation of an interface. Like the moment you talk about a folder, like now, if I'm talking about this folder that I'm calling it OS, this folder becomes a metaphor because as a user, I'll be able to have a knowledge on what is supposed to be within that folder. So automatically, I can be able to see inside this folder, we have files. So that is something that comes in our mind. It is an interface that presents some action or implementation of an action in a user's level, because you'll be able to understand that somewhere we are having a folder, we must have some files inside, or we must have some document inside it. So that is now what we can give. So we can say a metaphor can be a file, a metaphor can be a folder. Because when you look at a file, what do we have within a file? We have some records. When you have a folder, what do we have? We have some files inside it. So that it becomes now a metaphor as a presentation. Is that okay?
Yeah, it's okay.
Yeah, so if you look at that, what are you looking at in terms of topics that we have already covered?
I think I just revised all the papers, then wrote
you
them
revised
down.
all the paper. Now, was there any challenge? Now, if you are given that paper now,
Yeah.
how many marks can you give to yourself?
I think 90%.
Yeah?
90%.
Okay, 90% is okay. So have we covered everything?
Yeah, that's everything.
Okay. Is there any issue on algorithms?
No.
No issue on algorithm?
Yes.
When you go to memory management, when you go to process management,
Yes.
maybe we can get give an overview of what I expect maybe you to understand.
Yes.
You need to understand mostly on these algorithms. Remember, we cannot, and if you look at that paper that we have, and then you can maybe look at another paper that we have. We find that most of the questions that are within that paper, they come from process management. And in process management, we cannot miss a question on algorithm. Is that true?
Yes, true.
Yes. So you must be given some questions from the algorithms. Then the next questions on process management that you can maybe come across is what you call, just a minute. Well, from algorithms, what we can't miss on that is what you call the deadlock. Now, I want to ask a question, maybe there's a revision. If you don't know the answer, you say you don't know, because we are now, we are acting as teachers, because now we have covered the syllabus. Now, there is a deadlock. And in deadlock, we look at what you call IPC, interprocess communication. And we say in interprocess communication, we are supposed to look at two modes. We look at what you call cooperating process as a type, and non-cooperating process. So when you look at these two types of processes that we have, if I can go back to cooperating process, we said we use what you call shareable processes. So this is where we have shareable processes. And in these shareable processes, we are saying we can have two modes on shareable processes. One is what you call the wake, and the next one is what you call the what? The sleep. So you wake up the process, or the process can sleep. So in that now, this process is not executing because of some block within them. It is because of a deadlock. It results because of this deadlock. Now, which are these strategies can we use to solve the deadlock conditions that you have? I know we understand about this deadlock condition. One of them is what? Before we go to the strategies.
Process leading to deadlock.
Yeah, that is a condition leading to a deadlock. Conditions of a deadlock. One.
Mutual exclusion.
Yes, mutual exclusion. Mutual exclusion. Then we have no preemption. No preemption, and many others, etc. Because I have seen you can recall that. Now, which are these strategies that you are supposed to solve? These conditions that we have. Remember, that is a question that you can't miss in your papers, either as a way of now interpreting in terms of how you understand it, or in terms of what you have written on your notes. Yes?
Yeah. We have sequential ordering of requests. Sequential ordering of requests.
Okay, let me write it. Sequential
ordering of requests to prevent circular waiting.
Yes. Sequential ordering. Then the next one.
Preemptive scheduling.
Let me write it first before I comment. Yes.
Complete allocation.
Complete allocation. Yes.
Simultaneous access to a resource.
Simultaneous. All these are strategies that you can use. Simultaneous
access to a resource.
Simultaneous access to a resource. Yes, that is when you can. All these are strategies that you can use. Sequential ordering. Maybe when you say this is the first process that you are supposed to execute, we can do that. So what we are doing what you call prevention. So we are preventing deadlock. So when you do what you call preemption means what? There are two ways, preemption and preemption. Preemption is when you remove. Maybe this one, we can do what you call avoiding. Avoiding some executions, because now these executions are leading to some deadlock. That's why we terminate that execution. Maybe complete executions. Maybe at this one, we can say maybe we are preventing, or we are preventing stroke detecting some executions that has to complete. We complete them fast. So all these are as a resultant of what we can call them strategy. I'm okay with that. But if you ask three main, we have prevention, avoidance, and detection, because these ones are the main deadlock prevention, which now are now resulting to either sequencing of these jobs in the execution or preempting or maybe completing the allocation or simultaneous access of these processes that we have. So in that case, we can say there are three main strategies, of which now these still are used on that. So we can also say that we can kill the process. There is another one that we can kill processes, and that can bring to what we understand about the strategies, or another name we call it the method. We call it the methods of solving that deadlock. So please, when you are revising, make sure that you understand about the process communication on deadlock and algorithm. Remember, we cannot miss a question on this, and mostly on a deadlock, it has about 6 marks on that. Yes. Any question on PROS management?
No.
Okay. I don't have any challenging question. I don't have any challenging topic that we can have within the PROS management. Those are challenging. Now, maybe we can move to memory management. Maybe you tell me the question that you came up across, or maybe you try to maybe to summarize. Don't give the whole question. You can go to the question, maybe you understand the concept, and then when you understand, you can be able to give the highlight, whether it is in memory techniques, whether it is in memory algorithms, or maybe other things that we have. So maybe we can look at memory management. Yes. Is there any challenging questions? Well, let me start from there.
No, not going.
Now, is it possible for you to understand about techniques? Are we okay with techniques?
Yeah.
Now, how many techniques do you know? Yes, Ezekiel. How many techniques do you know?
Paging.
You have paging.
Segmentation.
Yeah. Yes. Then we have what you call memory partitioning. Yeah. Memory partitioning, PTT. And this memory partitioning is the one that still maybe when do you know how to partition a disk when you have already installed the operating system?
Yeah.
Which step do you use? So when you are, maybe if I give you this, maybe let me go to a PC. In my PC, I have 3 drives. I have lock C, which is C. I have lock D, and I have lock E. Suppose I want to have another lock disk. So do you know the steps of dividing? Maybe this. Maybe I want to divide this new volume.
No.
Yeah.
No.
So the same way that we are talking about partitioning here.
Yeah.
It is the same way that we can try to create partitions here. And for you to do that, we always have to go to the managers. So you just go to PC. Mostly, if it is on your desktop, you can go to your desktop, you right click, and then you go to manage. So when you go to manage, there is a window that appears. This window that appears here, we have what we call the disk management. So all these are the disks that have been allocated to my computer. You can see we have the first one, which is a system reserve. Sometimes we say it uses what you call the basic partitioning. Basic, because we have two types of partitionings. Remember, for our case, we are not looking at types of partitioning. We are looking at types of partitioning as fixed partitioning and dynamic partitioning. But this fixed partitioning and dynamic partitioning can be grouped in terms of basic partitioning and what you call extended partitioning. So when I now divide it as a basic partitioning, if I move away from now, these two types, these are categories within the fixed and dynamic. When we say we have basic, we are saying this is a disk that has been created to be a local disk that can hold the operating system. This one is the disk that can be used to do other services that we have. And that's why, if you look at this one, we have what you call the system reserved. Meaning, this becomes what you call the basic, or what you call the primary partition, or what you call the active. And I think you can see it is written active or primary partition. That means when I do away with this, if I do this, if I try to do this, to do away with this, or I format, maybe if it can allow me to format, automatically I do away with a file that is called msconfig file. And this msconfig file is the one that allows you to start, or what you call to boot your computer. So if you don't have that start file, automatically we have some issues within the correction of the files that we have. Then if you look at this, local disk C, so this one is now storing the msconfig. This one is now storing all the files of an operating system. So we have all files, and that's why we can see we have boot. Then don't mind about this. This was created when I was recovering my operating system, and it took part from the extended view. And this extended view is what we are calling the new volume. And if I want to do another partition, of which I don't want to do it because now maybe let's try to maybe extend just a minute. It can't allow us to extend. If I want to create a new partition here, I just right click that volume, then I shrink volume. I shrink. So when I shrink, it gives me the size of the memory that I want to shrink with. Remember, when you are calculating the size of a memory, we said we use megabits. We use megabits. You're using megabytes or megabits. At the moment you're using megabytes, now it defines that 1000 megabytes or MG, maybe you can call it MG, is equals to 1 GB. So that is the equivalent. 1 megabyte is an equivalent, or 1 MB. Let me call it the way it is supposed to be called. 1 MB is 1000 MB is equal to 1 GB. So that means, that's why we are saying, if this one is now, the active one is 219,780. So how many GBs do we have? So automatically it's like we are having 219.78 GB. So in this case, I can maybe shrink this. Maybe I want to shrink it to 100. Or maybe I call it 1000. So when I call it 1000, I'm shrinking it to 1 GB. Where I can now shrink if I want to shrink, but for now I don't want to shrink it. Maybe I can shrink it. So can you see it has already created 1 GB unallocated.
Yeah.
Now, if I use this, maybe if I go back to PC, and then I try to format. If I try to format this, I'm supposed to see that drive here. When I have created another allocation of 1 GB. But because I don't want that allocation, maybe I can come here, go back to the mother of that location, and then I extend, I combine. I don't want to create that partition. So can you see now I have combined the locations?
Yeah.
That is now the way we say partitioning. So the moment we are partitioning like that, and maybe I am creating that partition that I have already created, maybe let me shrink again. Maybe we call it 1000 so that I can explain. If you look at this allocation, automatically we can now create what you call fixed partitions within it and dynamic partitions within it. It depends with an operating system, and it depends with the size that has already been created, whether you want to have a size which is dynamic or the size that is fixed. So in this case, we'll be able now to create partitions inside here. And that's why we can see this memory is not activated because we have not created a new one. Because when I create a new volume, so it means that now I am formatting it. So when I create that volume, I'm formatting it. And that's why I can give it to drive G. Or if I want to change that, maybe I can give it to drive Z if I want to change. And if you can see here, all the drives that are given, like now we have D, if I can remember, and we have C drive, and there is another drive. If I'm, maybe we can go back. I don't know whether we can go back. We have D, and we have E, and we have C. So if you look at this drive, you can't see those drives here. So in this case, we are now doing what you call demand paging. So in this case, we demand page. We remove it here, we take it to here. We can remove it here. When you change this name, maybe I don't want to shrink that. When I try to change this name, and maybe is it able to allow me to rename? Maybe I can format, maybe I can do I don't want to change that. Let's see, maybe whether I can go to properties. Okay, it can't allow me to change when I am in this position. Maybe let me go to PC. I see whether it can change. Maybe I go to this and I rename. This is given automatically. That's the problem. It gives it automatically. It gives this drive automatically. That's why we can't change. But if we can change, if we can change this drive automatically, when you move to this drive where we have a new disk, automatically you will not be able to see that drive here. We will be able to see it here because I have already. If I delete and I format, maybe I say I format that part, automatically I will be able to see that drive here. So that is what you call demand paging. So in that case, so because I don't want to create another partition, let me do what you call extension. So I can extend. I can extend so that I combine that drive, the whole of that drive, the way it is. So I combine it the way it is, and that becomes the end of what we can be able to define what is partitioning. So that's why we say in partitioning we have what you call some fragmentation. We create what you call fragmentation. It depends with the file system. If you look at what we were doing, we were using NTFS. Have you seen the NTFS somewhere when I was shrinking?
Yeah.
Yes, that NTFS means that now we can now carry all the properties of an NTFS. And one property that we have on NTFS is to always make sure that we can do what? One property is to make sure that we can do what you call backup. We can do what you call recovery of data. Maybe we can do some extensions of our data and be able to improve in the process executions. So all those are advantages of a file system that we have. If you look at this, this one, it was created through FAT32 because the operating system that I was trying to recover, it was using interface. it was using interface 32. That is what you call x86. x86. Are we understanding? Are you understanding now?
Yeah.
Yes, Hamza Marin, welcome to my class. Hamza, you can't hear me? Hamza, can you hear me now? Hamza amepotea.
Mwalimu, maybe another question.
Yes, yes.
On something to do with directories.
Yes, yes.
File directories, tree directory, acyclic.
Yes.
Well, I didn't quite understand them.
Oh, you did not understand them. So can we go back to those directories?
Yeah, we can.
Okay, so if you look at what we said about directories, we have one level directory. Maybe I can have another slide somewhere here. So we have what you call the one level. These are types, eh?
Yeah.
These are types of directories. One level directory, two level directories. We have three level directory and a cyclic. And a cyclic graph directory. Now, when you look at the one level directory, this is very simple because now we are looking at one entry. So this is where we have only one entry. And maybe allow me to use Paint for the explanation purposes. And that's why we say that if you can remember what we said about files, we said they are classified in different types. Either we have a document file, we have a PDF document file, we have an RTF file, we have a CSV delimiter file. Maybe we can open one application somewhere. Maybe we can see that those file types still, they are supposed to be used together. Maybe if I try to save this file, and maybe I want to save it maybe on my document. Just a minute. Okay, so that is now when I'm saving this file, all these, maybe we can have what you call the PDF file. We don't have those defined, they are not defined clearly. Maybe you can have text file. Some of them we have. We have CSV file. The moment we are talking about Excel, we can save it .csv. And that one can be used in another area. So for now, let us understand that we have those types. So those types that we have are the ones that we are supposed to use them as directories. And that's why I remember I said, don't cram. Maybe don't cram those directory because you can have your own directory. And the first directory, maybe I can call it directory A. The next I can call it directory B. The next one I can call it a document directory. Because we say still file can be directory, then I can have another K. Maybe I can have another one L. So if I have these two directories, just a minute. I have K and maybe I have L. So if you have these two directories, this is where we are saying we have only one entry. We have one entry. We are entering to this, you access your file. This person enters, you go to a certain directory, you access the file. So that's why we say we can represent them using this file. This is a presentation of a file. This is a presentation of a file. Meaning, when you are accessing directory A, we cannot allow you to access directory B. We access directory at a time. There is what you call one access time. One user accesses one directory at a time. Just look at a point where you have your computer, maybe I call you Ezekiel, And then we have another person called Kamau, maybe if you have two people. You are accessing a computer. If Kamau want to access your file, cannot access until you complete with those files. That is what we are saying. Look at the computer that we are using. Currently, I'm using my computer. Nobody else can access this computer until I complete with that computer. So that is one entry where you access one directory at a time. At the moment you're accessing directory at a time, you find out you are creating different levels of the files. So this file, I can call it file 1, and this here I call it file 2. So this directory cannot allow us to access the file 2, but this directory can allow us to access the file 1. Are you getting that?
Yeah.
Hope you are getting that. Michelle, welcome.
Thank you.
Yes, and please, you are sleeping. And I know, I think I will give Ezekiel that mandate of being a class rep now. Is that okay, Michelle? So you'll be assisted by Ezekiel, because I have seen you two, you are very serious with this. So please, munaniamushia hawa wengine bana, at least tufanye revision bana. Sitaki muanguke bana. Hata corona ikiwa. Yes. So what we are saying is that in this one level directory, we have one entry, and this one entry that we are having, we can only access this file one at a time. So meaning the directory here, it has to, if I want to access B, I have to close this directory. If I want to access B, I have to close directory B so that I can access this directory. Unless we have different users, but now it doesn't allow different users. It is one user at a time. If it is me who is accessing my computer, I complete with it, I give it to you, then I give it to Michelle, I give it to Ezekiel, maybe I give it to Marie, etc. So the disadvantage with this, we said, when you are having this way of accessing file using one level directory, we cannot allow many users to access these files. We only allow one user to access a given file at a time. And this is now the one that is resulting to delay in the execution. It is still the one that is delaying in terms of what you call sharing of these files, because we cannot share files. Our main aim when you are having this directory is to have what you call shareable files. But if we are not having shareable files, my friend, we are doing away with what you call inter-process communication. And we can see it is part of the process execution. Are we understanding in that one level directory?
Yes.
Michelle, are you okay now? Or you are okay before? Because that question was for Ezekiel.
Yes, I'm okay.
Oh, okay. So the next one that you are supposed to look at is what you call the two-level directory. And when you look at the two-level directory, this is where we say now at least we can allow many users. We are allowing many users to access file, and this is where we have the master file. And this master file is the one that is allowing us to have many users who can access these directories, and they can access directory at different levels. So how do we come up with this diagram? So if I want to come up with a diagram for this, maybe I can do away with this page first. Remember, it is still recorded. You can still see your document. If you look at this, we are having now this directory. This is where we have the master file. This is where we have the master file. And when you have the master file now, you can allow us to have what you call the directories inside it, where I don't have any limit of having a directory B. I don't have any limit of having another directory C, which is not within the directories that we have. So in this case, in this directory, I can create a file. And this directory, I can create another file. But you can look at levels. You have level 0 and you have level 1. So we are looking at different levels. If you look at the first one, we are only having level 0. So meaning we cannot create shareable processes. But here, at least we have some light of now sharing processes because we have two levels. One level is level 0, the next level is level 1. Well, in this case, if you go to level 1, we can see now we have a file, we have a directory called B, and then we have another directory, see, the same directory that we have here, which can allow us still to have some files within it. Maybe it can have other directories within this. Maybe we can have D, then we can have E, which now have files, because that is the end of having files. This one can have file from top, and this one can have maybe files on that. So in this case, what we have trying to improve is the improvement on access, improvement on speed of access, mostly the speed of access. We have tried to increase on sharing of processes. Remember, processes are now shareable in a manner that processes are now able to create some shareable mode within their executions. And that's why we are saying, because now we have two entry, if I can call it in quote, two entry, because we have master, we are allowing many users. So in this case, instead of calling this directory A, B, C, D, now I call them user 1, I call them user 2, I call them user 3, I call them user 3, 4, and then I call it user N. Are you understanding that? Remember before that, we were having these directories, and because inside this directory we were having some files, so instead of having this directory now, we can call them users. So you have users here. And because now we have users instead of these directories that we are having here, here we have users. Now, our main aim is now to understand that these users can access many directories. The user 2 can access a file. The user 4 can access many directories. This user can access. So you are now looking at a point where one user can access many directories. Many users can share directories. And at that point, we can be able to understand that now we are having what you call the shareable processes within the two-level directory. But now, that shareable process that we are having, it is for users. User 1 sharing its file, user 2 sharing of file. What about now, where we can have users sharing files of user 2, user 2 sharing files of user 3? That is one thing that we don't have here. And the only way that we can be able to improve in this is to make sure that now we can be able now to have another directory that we call a three-level directory. Yes, are we getting now? Are we able to, Ezekiel, are you getting that?
Yeah, I'm getting.
Yes, Titus, welcome, huh? Mr. Titus.
Yes, mwalimu.
Yes. Kwani umelala aje bana? Leo umelala bana. Michelle and Titus, leo umelala. Next time amkeni mapema. Okay. So hope you are understanding those three-level directories, or those three directories that I have seen an issue with some students. Instead of writing 3, they write 3. We don't have 3 directory. Yes, we have 1-level directory, 2-level directory, but we don't have 3. If you write 3, that is not good to write 3. So let us now move to 3-level directory. In this 3-level directory, this is where it allows you to have what you call subdirectories. The main advantage of this is having subdirectories. At the moment you have subdirectories, what we can look at is we are looking at now creating shareable processes, improving in execution, because now if you have one process that is now sharing with another one, now we can execute it instead of now executing it in the other user. You can execute in one user. So maybe as a presentation, maybe I can still go back to this. And I want to go back. So instead of having master file here, here we have files or directories. We have files or directory, the way I have drawn them here. And what we can be able to understand about the tree-level directory, now it is creating what you call the subdirectories. And when you create subdirectories, it means we can have a directory here. Maybe I call it A and I call it B. Maybe because we have this directory, maybe here we can call it D. We cannot have the same name. Then here I can have another directory. Maybe this directory. Maybe you can have directory K and directory L. So in these directories that you're having, this one you can have a file, this one you can have another file, and this one you can have another file. Titus, can you switch off your mic, please? Yes, thank you. So if you look at this, we are having a directory. So we are having level 0, level 1, and level 2. So in this case, we are having a directory and a subdirectory. And because we are having a directory and subdirectory, we can still have other directory here. Maybe we can call it A, and maybe we can call it C. Where now this one has file, and this one we can have another directory called K, and maybe we can have M, which has some files here. And the chain continues. So if you look at the first directory A, it has K as a directory. And when you look at B, it has another directory, which is called K. In this case, we have some issues because we are creating file in different directory. So in a tree-level directory, it allows you to come up with what you call the subdirectories, but it doesn't allow you to do what you call shareable. If you look at in our execution, the main aim of coming up with this directory is to do what you call sharing of processes, to create shareable processes, to create multiple executions within that. And when you create those multiple executions within that, we can be able to understand that now these processes are sharing. But for this one, we are not having that. But one thing that it has opened up is that these directories, they can also be conned files. So directory can also be conned files. So we can now allow directory inside another directory inside, and that's why I remember when we were doing some practicals, I remember we came up with practical and we were creating a directory inside another directory. But the issue is we are not sharing. This one is supposed to share with this, but it is not sharing. It is not sharing. So we are having what you call duplication. We are having what you call duplication. And when you have duplication, what comes in our mind is the size. So we will be having less size. So in this case, we will be having less size in terms of use. And that's why we will be saying, okay, we are having a very good directory, but now the memory are now, because they are not sharing, we will have duplication of these files. So we improve, we require a large capacity. We require a large capacity of the memory. We require a large capacity of the external drive that we have. Maybe if you are using a hard disk, or if you are using any other storage that we have. So in this case, we can say we have some issues of sharing processes. And the only way that we can be able to improve this is to go to the next level, which is called a cyclic graph directory, where there's a cyclic graph directory. It's sharing, it's allowing what you call the shareable of processes. And when you allow the shareable of processes, it means, one, you erase you raise the size of memory. So the memory is reduced in terms of use. I'm not saying you reduce the memory. If it was 2 GB, you say you have 1 GB. No, it is in terms of usage. So in this case, we have totally reduced the memory, because in this case, we can do what you call shareable of processes. And allow me to use the same presentation here, where if you look at this, I have already created K. So instead of creating this K, maybe creating a file for this K, automatically, we now do what you call shareable. So we can do what you call shareable. And I can move from K, I create this. So this file that is from a directory, it is now shared by this file, this directory that is from the parent directory. Sometimes we call it the root directory. So this one, we call it the root. So anything that is in a root directory, it is now shared. The same case, we can share directory. Suppose we have this directory, and this directory has M and has N. And maybe we can say here, we are only having directory. We are only having this. We can still say, share directory with another directory. So we share directory with another directory. So it means there is efficiency in the use of the memory. There is high speed in the execution of these processes that we have, and we have tried to improve in this execution. We don't have one entry. We can have different levels of entry. That's why when you're using what you call cloud computing, I know what you know what is. Do you know what is cloud computing?
Virtual.
Do you know what is cloud computing, my friends? You know, if you don't know, please, we are doing a revision. Nobody will be crucified because of that. So do you have a do you have it? Do you have that?
No.
Do you know what is cloud computing? Remember, this is a technology that is mostly used in our country, and the developed country, because Kenya is a developing country. But we can look at now, cloud computing is now dominating the market. Well, we say we have one computer that is sharing all the services. Like now, I can create my server as a system, where now, if you have your computer, you can be maybe searching some information from my server, meaning it is not a must to your computer to have the hard disk. You know, the purpose of a hard disk is to store the operating system. So the operating system is stored on this computer, which is mine. And when you switch on your computer, automatically you switch to my server. So in this case, you find that if I have a new operating system, I install in my computer, and you can still see it in your system, because now you are using my operating system as a server. Are you understanding that concept? Where now we are distributing services, either we use software as a service, whether you use application as a service, or infrastructure as a service, because those are types of cloud computing. Infrastructure as a service, and maybe other things that we have within the executions. Are we understanding on that?
Yeah.
Yes, so that is why we are saying, if you look at this method, we are able now to follow what you call cloud computing. We are able to use cloud computing because we can look at now sharing of the files that we have within the executions. Within the execution. Is there any question? Maybe if you have a question, you can ask. I would ask maybe Michelle and Titus. We started with PROS management, and Ezekiel presented a case study on issues on PROS management. So please, if you have an issue on PROS management, I said you can air it out so that we can discuss. Remember, it can be beneficial to you and beneficial to your friend. I hope you have gone through the question paper. And Michelle, we had a deal. You are supposed to scan your paper and then you send it to me. You have done that assignment. So it means you are sleeping. So can you do that assignment?
Okay.
Yes, and you send it because I want to post them to your portal. And I hope you have past papers. I know this class, I gave you past papers.
Okay.
Yes? Gao?
Yes, Mwalimu.
Do you have any question on PROS management? Do you have any question on those past papers that we have? My friend, don't say no. I know there are questions. So if I ask a question, you can answer. Serious? Now usipotea because naona nauliza swali ya student wengine wanapotea.
I'll go through it alafu ndakwambia.
Okay, sawa. I will still wait. Yes. So I think now, Michelle, do you have any issue on PROS management? Have you gone through the paper? Any paper? I remember I said you go through the 2016. Was it 2016 or 2017?
2017.
I only have 2018 and 2017.
Okay, which paper, which challenge have you come across?
Even I have 2016.
Okay, do you have any challenge on those 3 papers that you have?
No, I was still looking at the 2016 one.
Now, what about 2015? What's the issue? You know, you are still adding on my buffer. That's when you go to 2015, you are still adding on buffer. So I'm now looking from 2015 to 2018.
Okay.
Any challenge? Does it mean that you have covered everything?
No.
Eh?
No. I was still.
But let me give you that homework. That is a takeaway assignment. You go through those papers. So please, if you have 2015, and maybe your friend does not have any paper on 2015, or he doesn't have a paper on 2016, 2017, please, can you distribute those papers?
Okay.
Maybe you can take a photo and then you distribute. And we are favoring our course. Remember, we are doing digital. So this is our course, and we should embrace it. And that's why I'm worried if I see some students who are not coming to this class. And they need to communicate. If it is an issue, they need to communicate. If it is bundles, they need to communicate. I can understand. Understand that is a challenge that we have. So that we can do. There is one student, I can't remember the student name, was saying he cannot see the notes, but I gave the guideline and I said, can you attend the class? And this student was not attending. So please, if you have a friend who is not accessing the note, can you tell him to access the note? And still, it is important to attend the class. Okay. So have I, Ezekiel, now I think this was your question on directories. Do you have any question on those directories that you have already tackled?
I think I'm comfortable now with them.
Okay, so remember that is another question that you cannot miss in your next exam. Are you supposed to do your exam in July? Studio?
Vile walisema, I think they postponed to November. That is if it's still.
They postponed to November. Oh, the July exam, it was postponed.
Yeah, because schools can't be opened.
Yeah, because according to the government, maybe wanasema from September, but we are hoping maybe we can open before.
Yeah.
But even though we are doing it on November, don't worry, because we must do away with the semester. We must do away with the year one. So we must be attending these classes. It is good to attend. And I said you can ask questions, either using any other platform. You can still ask. I don't have any issue. I can answer that question. And Titus, are you doing diploma?
No. Hapana mwalimu.
Oh, okay. So diploma walihama.
Niko mwalimu.
Inakaa hivyo.
Oh, ni Ezekiel. Mafrendi wako walienda wapi bana?
Kina Ruto hatujaongea nao late.
And then, is it yesterday we had, are you in the structured programming class?
Yeah.
The current one, or maybe the one that we created aside?
The
one that we are using Google Meet, which one?
For Google Meet, I attended the last class last week.
Okay, still tomorrow we have another class using the Google Meet, eh?
Yeah.
Yes. So if there is no question, maybe Titus and Michelle. Michelle, do you have any question? Titus, do you have any question on these directories?
Directories, I'm okay.
Directories, you are okay. What about now the techniques used in allocation or the allocation method?
You can repeat there.
Okay. Ezekiel, do you have any issue on that?
No.
Titus, do you have any issue?
Nazipitia mwalimu alafu kwa sasa
Ezekiel, do you want to mean that you are not there when we are discussing them?
mwalimu nimepata halfway.
Na ulienda through the videos yenye nilikuwa nimerecord?
Ndio nafanya hivyo saa hizi.
Is it audible?
Yes.
Oh, okay. So can you go through them? I will repeat them because Michelle has said unaangalia Michelle hata ikiwa simuoni unaona kuna shida kidogo.
Oh.
Okay, so I can repeat those techniques and maybe we can do a recap on that. And if I can go back to my PowerPoint, maybe we name them. One of them, we said we have what we call contiguous allocation. Maybe allow me to move to the next page. Remember, these notes are still recorded. Some students can access them. So allocation methods. So one of them, we said we have what you call contiguous. Then we have what you call linked. Then we have what you call indexed. Another name for linked is what? Is it chained?
Yes.
Chained, eh? Now, if you look at contiguous, I remember I said this is one of the simplest method, and most of the operating systems that were using this was Windows, Windows NT, Windows XP in that. And because of it was not flexible in terms of access, that's why we moved to chained. So in this allocation, it was using, if I can define maybe contiguous in a way that we can be able to understand, is following each other. Let me define it like that, following each other. So if you have element A, then we must move to element A plus 1. So what am I saying? I'm saying we are moving from A element, we move to the next element, A plus 1. If you move to the next element, it will be A plus 1 plus 1. I think that is the change that you are supposed to follow. I think you can understand that. And then we follow in this way. maybe if you're using the paint, maybe I use paint as a blackboard. Remember, I'm not using a whiteboard. I can use whiteboard as a paint as a whiteboard. So we are using now memories. We have these directories, and the memories that we have, we need to allocate these processes, or we need to allocate these directories that we have. So the first one, we start with 0. Remember, the directory, the index is supposed to be 0. We have 1, we have 2, we have 3, we have 4. Allow me to end at that point, etc. But in this case, what we need to have in our own way, we need to look at what you call the files. We need to have files, and then we need to have the size of that file. We need to have the size of that file. So the moment we have the file and we have the size of that file, maybe you have file A. This file has size 5. So this size means, in contiguous, it means we have 5 allocations. But these 5 allocations, they must be allocated contiguously. Meaning, we must have what you call the start file, or the start allocation. Suppose the start allocation is at point 2. And we need to allocate these 5 files that we have. So automatically, we start from 2. We allocate here 2, 3, then we move to 4, 5. That is 4. And then we can have another one here, which is supposed to be 5. 1, 2, 3, 4, 5. That is what we are saying. These are allocated contiguously. They are allocated contiguously, meaning we are allocating one file after another. Suppose now we move to B. Maybe we are moving to B, and before we even complete with B, we want to add the size of this file A, and we call it size 6. Let's say maybe this file was having 2, and maybe it was supposed to start immediately after the next file. 2, 3, 4, 5, 6, 7. Maybe it was supposed to start at 7. And we allocate. This is now B. So it means when you want to allocate B that has been added as a size here, which is size 6, so automatically we cannot contiguously allocate them. What we have here, we have what you call fragmentation. And the moment we have fragmentation, this results to what you call delay in execution. So we have delay in executions. And the files are dispatched, meaning the speed reduces. And because the speed reduces and even tracing of this file is hectic, maybe we have some issues on accessing them. Because when you're accessing them, we have to access files contiguously, but because we are not able to access these files contiguously, we are jumping the file for B. And maybe we are saying file B had about 5 or 6, and we have allocated them. Then for file B, we allocated, for file A, we allocated here. Now we have to jump through these. Now, which method are we using to access them? We are using what you call sequential method. We are using what you call a sequential method. At the moment we are using a sequential method, automatically we have a long process of access. And if you have a very long process of access, we have some issues over memory size. And we need to do away with the memory unutilization. Is it clear? Michelle, do you have any issue? I think the question was yours.
Yes, I'm okay.
You're okay with the contiguous titles now? I think you can understand it.
Yes.
Yes, because
Yes,
now
yes.
Ezekiel, I think Ezekiel is okay. Yes, Ngao?
Yeah, I've understood, Mwalimu.
Oh, okay. Now the next one, because now we are trying to reduce, we are trying to make sure that we can have fixed size in terms of use, and we can have the right access without within the executions. Now, what we can be able to understand here is now we need to move to what you call linked. Linked is like we are having what you call a conveyor belt. Have you ever watched a movie on conveyor belt? Ushai watch your movie na kwanga na mambo ya conveyor belt? Okay. Hiyo si movie tunaongea mambo yake hapa, lakini it works with this method of linked, because it's like now the moment we have some connection, because I can use that one as an explanation. The moment you use connection, it means we are creating what you call pointers. For those people who are doing structured programming, exactly, you can back up that. When you're using pointers, we create some address. So it's like now we are forming some presentation. We are having this, then we create a pointer. So this becomes a pointer. If this is file A, and here we have another file B, so it means this file B is being, this file A is being accessed by file B. So if you do away with this pointer, now you are doing away with all files. So what are we saying? We are saying, if you are using the same presentation that we have here, and we want to allocate files in this allocation, the same way we are supposed to allocate, maybe we are supposed to start from 2. We get a chain there. We chain to 2, maybe we chain to that. So what comes in this, we need now to look at now, when you are using this allocation, we must know which are these files. Maybe we can say the file 1 is 3, the file 2 is 6, the file 3 is 8, the next one is 9, the next one is 2, maybe. So all these are files that we are supposed to access. So in this case, we are not even following the contiguous way of allocation, but what we say is that maybe we come to this allocation, we move from 2, so the pointer is at point 2, then the next one that we are supposed to move to is number 3. Remember, 3 is closer. So we move to 3, then we can move to the next one, which is maybe 9. So in this case, we must note, so that is now the question that you should ask. How do you know that we are supposed to access 2, then we go to 3, instead of accessing the way they are supposed to be accessed? So when you are using this method, we follow first come, first serve. And when you are using the first come, first serve, and we say the starting point is at point 2, 2 is not as the first come, first serve, but it has been given that priority. And because it has been given that priority, we start moving from 2. Then the next one is supposed to be 3, then we change to 6, then we change to 8, then we change to 9. Now, it means that now, if we are looking at this point, we are looking at chains. We have chains. We allocate that. So it means if these are the files that we have, this is the last file that we are having here in this allocation, we'll see if we do away with this pointer, this file will never be accessed. If we do away with this pointer, all these files will never be accessed. So we have some hindrance in the access. And because we have some hindrance in access, we don't have what you call efficiency in the access. We have loss of access. So efficiency has gone. Access, at least we can try to say that now the mode of access is easy, because now when you look at the mode of access, we can use sequential or serial access, because we move from one point to another without omitting the files that we have. But the issue is when we don't have a pointer. The only way that you can solve that issue is when you are using what you call the indexed sequential. And I don't want to explain this because you have covered this in ICT. And because now we are doing operating system, I so repeat that. When you look at index, we are using indexes, or what we call the key fields. What is a key field? Have you done database, my friends? Have you done access?
Yes.
Yes, what is a key field? Now you understand what is index. If you have done database, and you have done maybe practicals on access, or maybe you have done on MySQL, maybe you are using MySQL. But I know for the introduction part, you use access. So if you look at what we are supposed to look at in eDex, we use key fields. So it means one file has an associate files that we are supposed to have. And these associate files that we are supposed to have, we should be able to look at now. Maybe we have file A, which has an index 1. Maybe file B, which has another index. So it means if these files that are supposed to be accessed from 10, so this index is the one that is storing all the files. It's like we are having a briefcase right now. Most of the readers use briefcase. I don't know why do you lock your briefcase? Michelle, I think you can assist us. Why do you lock your briefcase at home and you are on your mother? So that is the case. So we are locking processes here. Michelle, you explain that. Can you explain to Titus and Ezekiel, because I know why. I will not explain why you lock them, because you have some hidden agendas. I'm sorry to use that word. Okay. So if you look at key fields that we have, it is like you are doing what you call locking. So you lock. Nobody else can access that. The only person who can access that is a person who has been authenticated. And this person who has been authenticated now is a way of using some files that you have already given out here. And that's why we are saying, suppose now the files that has already been allocated here is file A and B. So these files, they are using this index, which we are calling 10. And because we are using this index 10, it can store all the indexes. Meaning, for this case, it can give what you call opening up of some access. Because if I want to add files, it's easy for me to add. The same way, when you're using what you call the change method, we were able now to add other files the same way we can add to this index. But you find that it is more easier for you to access the files when you're using the index, because if you can be able to go to the exact file automatically. And that's why I'm saying if you use the briefcase that I'm still giving as an explanation, I don't give that as an example in your exam because I will give you a 0. So if you now use that as a briefcase, you know where all the points are. Maybe you know where the makeups are, you know where the dress is, maybe you know where the eye pencil is, and even if you close your eyes, you can move directly to it. And that's why you lock that. I have given you an answer of locking your briefcase, because you don't want the interference. So in this case, when you lock those files that we have, we are saying, can you go directly to that file without loss of data? And automatically we have improved efficiency, we have improved robustness, and we have improved what you call the amount of flexibility in terms of use and in terms of access. Michelle, have I mixed up? So my members, are you understanding? Michelle, are you able to understand now? Have I opened up the understanding on that scenario?
Yeah.
Yes, Michelle, I think you are you asleep? Are you watching this when you are sleeping?
No.
Oh, okay. So, Titus, are you okay now?
Yes, I'm okay, Mwalimu.
Ezekiel, are you okay?
Yeah, I'm okay.
Ezekiel was okay.
Yes.
My friend, can you wake up? Huh? Can you tell your friend to wake up? Diploma. Watu wamerara bana.
Yeah.
And you know that you are supposed to do PASCO. We have a lot to do.
Yeah.
Yes. Any question? Now I can give you now views. You can give views, comments. Maybe have you understood? If you have not understood, I will be able to repeat it again. I can still repeat. Are we okay?
Yes.
Now, where will I start from next week now? Now, what I want you to do, each and every person will have a presentation. No, okay, I cannot say presentation using maybe some documents. Maybe you can have your own presentation. Please, Ezekiel, I think you have done a good job because of what you have talked about the first one. Michelle, still you
Yeah.
have done a good job on that. Titus still. But I would urge you, please, can you go through those past papers from 2015 up to 2018? Then you
Yes.
try to weigh out. Now, I want us to come up with another strategy here. I want you to go to those questions. Remember, we have time. You look at all the questions that we have in process management. How many questions have been asked within the first paper up to the last one? Now, ukiangalia, which are the most frequent questions that have been asked? Is it process management, memory management, device management, or any other topics that we have already covered? And then after that, you can tell me the weak part, then we can be able to repeat it, the whole of it. Sirio? So please go all through the past papers that we have. Then if you come across a challenge or a challenging question, you are good to go. And I said you can still use WhatsApp. You can WhatsApp me so that I can maybe get the feedback before the class so that I can prepare myself to that class. Or we can prepare ourselves to that class. I can still post. If you get a challenging question, post for WhatsApp. I think you have our WhatsApp. You post it. Maybe we can create a WhatsApp class for operating system from 3. Ezekiel, Titus, and Oro, you can be a group member. You can be a manager for that. So can you manage that? Be an administrator for that. And you try to incorporate all others. You add me, you have my number, you can add me. Then we'll be posting those challenging questions in that portal. Then after that, when we come to class, we'll be able to know where we start or where we will start.
Yes.
Is that okay?
Yes.
Yes. So I think we can go to the chat room. Maybe we try to. I want you to go. There is a forum I have already created. And the forum that I have already created is about metaphor. Can you go and challenge yourself? Maybe you can write your own understanding of a metaphor in operating system. Don't give me answers on metaphor that you discuss in high school or primary school when you are reciting poems. This is about metaphors in operating system. So go and look at that topic. It's just a metaphor. Just try to come up with an interpretation. What is a metaphor? What does it do? Then we try to pose some question. I will be there waiting for answers. I will still be answering because a forum is a way of now challenging each other. Ni kama tunachallenge. So you come with your own answer. I challenge it. Then when I challenge it, I tell you, why have I challenged that question? I give examples, maybe you challenge the example, you give another example. So can we go to the forum, please? And maybe we challenge those questions. I have already posted the question and it was supposed to start at 9 and it's 9:45. Maybe I can add some duration at time that it's supposed to end so that we can be able to move forward. Are we okay?
Yes.
Yeah.
Okay. Thank you for listening. Maybe we can move to that forum, then we proceed. So please, can you tell your friends to come to class? I have about 4 students who are supposed to be in this class and they're not attending. I'm worried. So please advise them.